Hello friends, very good morning. Myself Dr. M.H. Chennaya, and in today's video we are going to work out a problem on a welded joint which is subjected to a tensile load. Friends, the question for today's video reads like this. A steel plate of 55 millimeter wide and 10 mm thick is to be welded to another plate. I have written the diagram here. This is a plate which is to be welded to the second plate here by transverse weld. Friends, when you say transverse weld, it is a weld which is done normal to the load axis. This load is acting perpendicular to the weld. And here he has asked us to find out to determine what should be the length of weld to sustain a load of 40 kilonewton under two conditions, that is when the load is static and the second is when the load is dynamic. Friends, you know very well that a normal weld or a transverse weld fails by tearing, and the tearing stress or the tensile stress, KCI will take the tensile stress is given by the formula sigma tensile is equal to P divided by 0.707 H into L. So this equation is available in the machine design data handbook. I am considering case 1 when the load is static. Both for static and dynamic loads, we make use of the same formula, but the value of the sigma t will be sufficiently lesser in case of dynamic load. I will take up that case separately. So friends, here the sigma tensile is given to be equal to 100 Newton per mm square. This is given in the data, and load P is 40 kilonewton. This is 40 into 10 to the power of 3 Newton. And friends, the value of H is the thickness of the plate, that is 10 millimeter. I have shown here, and the load is given to be 40. Friends, if you make this substitution here, you are going to get the length of weld for this case, that is the load is static, is equal to 56.577 mm. This much of length is required. Friends, if you compare this length of welding with the width of the plate, you find the length of welding required is higher than the width of the plate, and hence a single transverse weld is not sufficient. So L is equal to 56.577, which is greater than B, that is the width of the plate. Hence, we adopt double transverse weld. That is to say, whatever the length of welding you are getting here, that length of weld is divided equally. Half the welding is done here, half below this, on the bottom side of the same plate. Therefore, length of weld L on each side will be just half of this, is equal to 56.577 divided by 2. That works out to 28.28 millimeter is the length of welding required on each side. And friends, for the length of weld so obtained, you will have to add 10 millimeter extra for starting and stopping of beads. That is, add 10 millimeter extra for each length call starting and stopping of beads. Stopping of beads. So whatever the length you get, that is 56.57, that is 28.28 plus 10. Therefore, length will be equal to 28.28 plus 10 mm, that is 38.28 millimeter is the total length of weld required. Friends, we'll move on to the second part of the question, that is, what is the length of weld required when the load is dynamic? So friends, we make use of the same formula. Case B, the load is dynamic. Friends, we use the same formula. Sigma tensile is equal to P divided by 0.707 H into L. But there is a small change, that is, here this sigma tensile, whatever the value you have got, that is to be divided by a fatigue stress concentration factor, which is obtained from machine design data handbook, and for a normal weld or a transverse weld, that factor is 1.5. So I'll write down here the sigma tensile is sigma T given divided by fatigue stress concentration factor, that is equal to P divided by 0.707 H into L. Friends, sigma tensile is given to be 100 divided by 1.5, that factor is equal to P is 40 into 10 to the power of 3 Newton divided by 0.707, H is 10, L is the length of the weld required. And after simplification, friends, this value of L works out to 84.86. 84.86. We get L equal to 84.86 millimeter. Friends, if you observe case 2 with case 1, the length of welding required here very obviously is higher than that obtained in case 1, that is for the static load. And again, this is greater than B, the plate width, and hence we adopt double transverse weld, and the length of weld on each side is equal to 84.86 divided by 2, that is 42.43 mm. Again, as you have done in the case 1, you will have to add 10 millimeter extra for each of these welds on both the sides to take the complete length of weld. Friends, I hope the presentation was interesting. Please go through the complete video, share with your friends if you like this video. I thank you very much for watching my YouTube video. Have a wonderful day.